Alright, in this video we're going to learn how to solve, again, equations of the same form as we saw in the previous video, but in the case that the initial guesses that we're going to make may overlap with solutions of the homogeneous problem. That refers to step 3 of the algorithm I gave you in the previous videos on how to solve this. And let's illustrate it with an example. Now, again, with an equation like that, always the first step is to find the homogeneous solution, because the general solution is the sum of the general solution to the homogeneous problem plus the particular solution that we will find with a guess. That's theorem 3, right? Anyway, so let's find xh. To find the solution to this homogeneous problem, well, it's easy. We write the characteristic polynomial. And in this case, the characteristic polynomial is lambda squared plus 8, this is an x, of course, plus x lambda plus 16, right? And this is a very easy characteristic polynomial to factor. This thing is lambda plus 4 squared. All right, so we have that lambda equals minus 4 is a real double root, or a double real root. Okay, now we use the algorithm that we know of what the solution is like depending on the roots of the characteristic polynomial, and we know that in this case, this is going to be the exponential of lambda t, so exponential of minus 4t, that multiplies a polynomial c1 plus c2t in this case, because it's double root. You go to the multiplicity of the root minus 1. All right, wonderful. Now we have step 1. Step 2, let's make a guess for the particular solution. So, first guess for xp of t. Well, looking at the inhomogeneity, our first guess should be a polynomial of degree 2 times an exponential. So it should be xp of t equals e to the minus 4t alpha t squared plus beta t plus gamma. Now, step 3 of the method, check if the particular solution overlaps with the general solution to the homogeneous problem. And it does. If you see this thing, it's equal to e to the minus 4t alpha t squared plus, let's call it xp prime or something, xp prime, or maybe if you want xh, one particular case of xh, right? E to the minus 4t bt gamma is 1, actually is overlapping with the 2 solutions of the homogeneous problem. That is not a good guess, because, I'm going to write it here, these two terms overlap with xh. Why is that a problem? Well, the problem is that we need, because this is a second order polynomial, we need 3 constants in here, and if we plug in this into here, automatically this is going to be cancelled, this is going to be cancelled, and I'm going to have only 1 constant. How do I know? Right, because I know that if I plug in this kind of equation in here, I get 0, because we found this is a solution when this was equal to 0. So if we plug in this thing, this part, multiplied by this is going to give you 0. These 2 constants will cancel, and we will have an indeterminate problem to solve. We will not find a solution in general. We may be lucky, perhaps, and find some cases where the degree of this is higher and will allow me to do that, but in general, this won't work. So again, the rule tells me that I need to displace, push out the particular solution out of the space of function generated by this homogeneous solution. Okay, the algorithm tells me, okay, how do I push it out? Multiply by powers of t. Let's do a second guess. All right, second guess. The second guess would be, all right, so you're telling me to multiply e to the minus 4t times t times alpha t squared plus beta t plus gamma. Is that good? Well, this thing is e to the minus 4t multiplying alpha t cubed plus beta t squared plus gamma t. Is this good? Not quite. Why? Because we still have this exponential with this. This has some overlap with C2, with one of the solutions. You see? This still has overlap. The linear term has overlap with one of the solutions to the homogeneous problem. So if we plug in this solution into this equation, we're going to have that gamma will cancel, and we will not have the three unknowns that we need to solve the system, because we have 3 degrees of freedom. We need 3 unknowns. All right, that doesn't work. So third guess for xp of t. The third guess is e to the minus 4t, t squared, alpha t squared plus beta t plus gamma. Is that good? Well, this one is e to the minus 4t, alpha to the power 4, t to the power 4 plus beta t cubed plus gamma t squared. And now, there is no overlap whatsoever between this one and this one. If this one had a t squared, there would be overlap, and we will have to multiply again by t. But there's no longer an overlap, so this is the valid guess. This is the guess that has no overlap with the homogeneous solution. All right? If you were to try this guess, it would not work. Math will tell you, you plug in this guess, and math will tell you, nah, there's no solution for the problem you're looking for, sadly. If you plug this other one, math will tell you, no solution. You plug this one, there is a solution. All right? Okay, so let's apply it. Now that we know what is the right guess, I'm gonna write it here. The right guess is, let's guess xp of t, it's equal to e to the minus 4t, alpha t to the 4 plus beta t cubed plus gamma t squared. And you see this happens because the inhomogeneity is of the same form as the homogeneous solution. At least it's got some overlap. You see, it's an exponential of the same argument. If this were a 3 here, or a 3 here, or a different number, there would be no problem. If there were a sign, there would be no problem. It's the fact that they coincide. The same exponential, and a polynomial. All right. All right. So let's do the routine. And if we do the routine, we find the following. So the derivatives of this are xp of t is already there. So let's do the first derivative. The first derivative is, I'll write them for you, minus e to the 4t that multiplies a common factor 4 alpha t to the 4 plus 4 beta minus alpha t cubed plus 4 gamma minus 3 beta t squared minus 2 gamma t. Please check it. This is just taking the derivative of that. Check that you get the same result. It's good practice. xp dot dot of t, it's equal to, it's a longer one, so I'm going to give more space. X dot dot p of t, it's equal to twice e to the minus 4t. That multiplies a long expression, 8 alpha t to the power 4 plus 8 beta minus 16 alpha t cubed plus 6 alpha minus 12 beta plus 8 gamma times t squared plus 3 beta minus 8 gamma times t plus gamma. All right, so we have here the derivatives of the function. We plug in these expressions into this equation, and when we do that, we end up when the exponentials cancel on both sides, and we get a polynomial on the left equals a polynomial on the right. So we equate the coefficients of all the powers. Now, what we get is the coefficients. I'm going to write, please do it. I'm going to write just the system of equations that you get of t to the 4. Now, very interesting. With t to the 4, you're going to get something like 16 alpha minus 32 alpha plus 16 alpha. With t to the 4, you see that there's only alphas with t to the 4 equals 0 because there's no t to the 4 in here. So you would get an equation 0 equals 0 that tells you nothing. If you only got these kind of equations, it's math telling you your guess was wrong, you're not getting enough to solve your 3 unknowns. You have 3 unknowns, and this is a known equation. That's what happens if you input the wrong guess. Because if you input the wrong guess, you get zeros because you're inputting solutions of the homogeneous problems. And the homogeneous problem is equating this to 0, exactly. You will get 0 equals 0 in those cases. Things like that. Or 0 equals 4. You see, either equalities that are not true, so assuming this is a solution, you get 0 equals 4. So either you get fewer equations that you can use, or you would get a wrong equality. If you get a wrong equality, this is math telling you your assumption is incompatible. You get a wrong expression, a wrong equality. If you assume this is true, you get 0 equals 4, so it's a wrong guess. That's what happens if you actually plug in the wrong guess, all right? But because we actually upgraded the guess, we're gonna get 5 equations, right? One for order 4, then we're gonna get the coefficients of order 3, we're gonna get the coefficients of order 2, we're gonna get the coefficients of the order 1, and the coefficients of order 0, which are the independent terms. So we're gonna have 5 equations, 2 of them will be useless, but no contradiction. If you find a contradiction, that means wrong guess, okay? All right, with t cubed, you get the following: 16 beta minus 32 alpha plus 32 alpha minus 32 beta plus 16 beta. And this is equals, sorry, on the right we get 0 because there's no t cubed on the right. So again, you get 0 equals 0, a non-equation, but still no contradiction, so we're fine. We still have 3 equations to go and 3 unknowns, so we better get equations here that we can use to solve unknowns. Let's see what we get. With the coefficients of t squared, we get 12 alpha minus 24 beta plus 16 gamma plus 24 beta minus 32 gamma plus 16 equals 1. All right, wonderful. So the nice thing about this, I'm writing all the coefficients without summing them because this is literally what you get when you substitute and you group. All right, so here, betas cancel, gammas, this is 16 gamma, sorry, my bad, I'm confused. Gammas cancel as well, 32, 16, 16. So we are left with the 12 alpha equals 1, which means that alpha equals 1 over 12. All right, wonderful. So we got what I know. Coefficients for T1, this is going to be 6 beta minus 16 gamma plus 16 gamma. That's what you're going to get, equals 0. Because the equals 1 comes because there's a 1 here, this coefficient. And the 0 is because there's no linear term. All right, so that means the gammas cancel. That actually means that beta is equal to 0. Okay, so I got another coefficient. Nice. Now, the independent term is just 2 gamma. It's this 2 times the gamma. Remember, the exponentials cancel because they're in all the solutions on both sides of the equation. So I get that 2 gamma equals 6. So gamma is equal to 3. Nice. So I got the particular solution. If I substitute the values in the particular solution, I get that xp of t, it's equal to e to the minus 4t that multiplies 1 over 12 t to the 4 plus 3t squared. All right, and this is the particular solution. This is half the solution. This is the other half of the solution. The final solution that I will write here is the sum of the two. So remember, x, I'll write a bit more here. X of t, it's equal to the sum of the homogeneous solution plus the particular solution to the inhomogeneous problem. So in this case, the solution is e to the minus 4t. We can take common factor of e to the minus 4t when we sum these two, and we get c1 plus c2t plus 3t squared plus 1 over 12 t to the 4. And this is the final solution. All right, I hope this is helpful. Again, if you get a guess, if you start making guesses, which is in this case, order 2 polynomial times an exponential, but this order 2 polynomial has 2 terms of overlap with the solution to the homogeneous problem, you need to upgrade the solution twice. And then again, solving this kind of systems is a bit tedious. We're not gonna be doing it anymore. This is just for demonstration purpose. What we're gonna practice though is how to make the right guesses, okay? And that's actually a typical exam question. Typical exam question is, what would be the optimal guesses that would work for the following, for the particular solution of some equation that is given? and not to solve it. Just give me the guess. What would be like the solution would be this one. That's the right guess. Let's solve exercises like that to get familiar. I mean, in assignments, we'll have to do the system of equations, but in the final assessment, which is the longer assignment that you get at the end of the course, I will probably ask you, if anything about this, is to guess make the right guess, the educated guess on the solution, on the particular solution. All right, so let's erase and consider more examples. All right, so here's the question. Make a guess that is guaranteed to work for a particular solution of this problem. X dot dot minus 6x dot plus 9x equals 5e to the 3t. Now, if we were naively guessing, we would say, oh, that's easy. It's a times e to the 3t, right? But again, to make a good guess, you first need to know what is the homogeneous solution, because the particular solution may overlap with it. So let's see what is the homogeneous solution. Find x homogeneous of t. How? Well, the characteristic polynomial. Characteristic polynomial, in this case, is lambda squared minus 6 lambda plus 9. Right? And this thing is actually easy. Is lambda minus 3 squared. All right, so we get that then lambda equals 3 is a double real root. Okay? Wonderful. So if that's the case, then the guess is, so the solution to the homogeneous problem is going to be e to the lambda, so e to the 3t times a polynomial c1 plus c2t. All right, so knowing that the homogeneous solution is that one, then we know that we need to make a guess. And let's do first the first guess. First guess. If there was no overlap, the guess would be easy. xp has to be an exponential, so a e to the 3t. But overlap, that doesn't work. There is overlap with this term, right? So we upgrade the guess. Second guess. Okay, so the second guess would be multiply by t, this thing. So xp of t, it's equal to a times t times e to the 3t. Problem with that? Well, that thing again is going to have overlap. Now it's going to have overlap with c2t. Horrible. Okay, so that is not good either. So the third guess, xp of t would be a t squared e to the 3t. All right, and then because this one is not a solution anymore, it doesn't overlap with xh, it would be a valid guess. Okay, so we are upgrading our guess multiplying by t. All right, so let's plug it in. So in this case, let's solve it, because actually this one is solved in the note, so I'm going to solve it as well. But in the future, we're going to just make the guess, okay? Let's find the general solution for this one only. But then we will do more problems in which we only find the guess. So in this case, if we take, let's just solve it for fun. We take the homogeneous solution to be that one, and then the guess that we're going to make is guess xp of t is equal to a t squared e to the 3t. All right. So if we make that guess, that's pretty easy, because xp dot is equal to, again, a chain rule. Let's do it with all the steps, right? So a 2t e to the 3t plus, it multiplies everything, plus t squared 3t squared e to the 3t. That's the first derivative. And now the second derivative, xp dot dot, it's equal to a that multiplies, that multiplies 2 minus 9t squared plus 12t e to the 3t. This one, again, is a to the 3t that multiplies 2t plus 3t squared. This is the same. All right. Okay, so what we're gonna do now is we're gonna plug in these solutions, this particular solution into the equation, and if we plug it in, we get a that multiplies 2 plus 9t squared plus 12t e to the 3t minus 6 a 2t plus 3t squared, right, plus 9at squared. Sorry, I forgot the e to the 3t plus 9at squared e to the 3t equals to 5 e to the 3t from the right hand side of that. Okay, wonderful. Then the exponentials cancel as usual, and we get the following equation. If we add up all the a's, so you can tell that if you add up the coefficients on the left and on the right, I mean, let's do them, right? The coefficients, we don't really have to do it, but let's do it for all of them. Let's do it just to be systematic. Coefficient of t squared. Well, on the left we get 9a from here minus 6a from here. 6 times 3, 18a from here plus 9a from here, and nothing on the right equals 0. So 0 equals 0, compatible, nice, we're okay. Solution. This equation tells you nothing, but at least no contradiction. Let's do the coefficients of t to the 1. Again, another one that will give me nothing. Let's do it anyways. This is 12a from this one minus 12a from that one, and nothing here equals 0 because there's nothing on the right, so you get 0 equals 0. All right, again, a non-equation, but also no contradiction. Finally, let's do the coefficients of the independent term. So in this case, we get 2a from the first term, nothing on the second, nothing on the third, and we have 5 on the right. Easy then. So a is equal to 5 over 2. All right, so we got a particular solution. Again, this is more than the exercise actually asked you. The exercise only asked you to make the guess. We are solving the full problem. We're actually finding the value, exact value of the particular solution. But now that we are in an easy one, this is 5 over 2 t squared e to the 3t. That's the particular solution, which means that the total solution x of t would be the sum of the homogeneous one, which is e to the 3t, c1 plus c2t, t, yeah, plus the particular solution that I can add as common factor to e to the 3t, so plus 5 over 2 t squared. That will be the full solution. Again, this is more than the exercise is asking for, but this is an easy one, so we might as well solve it. All right, let's do another. Let's do a quick modification on that one, shall we? All right, let's do it. All right, so it's almost the same. The difference is that instead of a 3, now we have a 2. Aha, so if we want to make the best guess for this, it would be, the first guess would be a e to the 2t, and that would be correct because 8 e to the 2t, there's no overlap whatsoever with that. All right, so that's an easy one. All right, let's do another. Uh-oh, didn't work. Okay, let's do that example. X dot dot plus x equals t cosine of t. So let's find a good guess for the particular solution. All right, so in this case, first let's find the homogeneous solution. So to find xh of t, first characteristic polynomial, in this case, is lambda squared plus 1. Remember, not plus lambda, plus 1. Plus lambda would be if it were an x dot, but it's not. So the roots of that is lambda, it's equal to plus minus I. All right, so it's a simple, complex, conjugate, okay, rather a pair of simple, complex, conjugate roots. Okay, so what we have in this case is that the homogeneous solution is of the form, right, A or C1, let's call it C1 cosine, remember alpha is equal 0, theta is equal 1 in this case, so it's C1 cosine of t plus C2 sine of t. All right, so now we have to make a guess for the particular solution. Our first guess would be a trigonometric times a polynomial, so of degree 1. So it would be, let's make it alpha plus beta t, and that multiplies, let's call this one maybe gamma cosine t plus delta sine t. All right, so actually you could remove one of them, but I'm not going to get into that. If you wonder yourself and you want to think about it, you could have done it like that and it would be fine. But not to confuse people, I'll keep it like that. And if you have questions about it, please ask me in the discussion sessions why you can actually take that one out and it would work. Anyway, so that would be the first guess for xp, right? Now, would this one work? Not quite. Why? Because this one overlaps with the alpha one overlaps with the solutions of the homogeneous. Second one doesn't. The solution of the homogeneous doesn't have any t's, but without a t, we have an overlap between this cosine and this alpha. So this first guess would not work. We need to go to the second guess, upgrading this with one polynomial. So it's t alpha plus beta t gamma cosine t plus delta sine t equals xp. Again, this is not necessary, but I'm keeping it, which is the same as xp would be equal to alpha t plus beta t squared, and then gamma cosine t plus delta sine t. That would be the right guess for this equation. All right, I hope it's understood. Let's do another. All right, so let's check this one. This one is an equation that we solved before, but let's do it with the homogeneous version. Now we have an inhomogeneous one. All right, first, remember, we need xh. For that, the characteristic polynomial, which is lambda to the 6 plus 3 lambda to the 4 plus 3 lambda squared plus 1. So this thing, remember, was lambda squared plus 1 cubed, which means that you have lambda equals plus minus I. In this case, is a triple pair of complex roots. This is from the examples we did before. Now, in this case, that means that the particular solution, sorry, the general solution to the homogeneous problem would be cosines and sines times polynomials. So we have the multiplicity here is 3, so we're going to have second order polynomials. So we have the cosine of t multiplied by c1 plus c2 t plus c3 t squared plus the sine of t. Remember, it's t because, again, alpha is 0, theta is 1. Theta, alpha is the exponential of alpha t times cosine of theta t. All right, sine of t, and then it would be c4 plus c5 t plus c6 t squared. That's the homogeneous solution. All right, now we need to make a guess for the particular solution. What would be a good guess? All right, so let's do a first guess, a naive. This is the naive guess, right? As if, like, without taking into account this homogeneous solution. Well, naively, we need a trigonometric times a polynomial. So I need, my guess would be x particular would be of the form polynomial of degree 3, which is alpha t cubed plus beta t squared plus gamma t plus delta. All right, and that multiplies another constant, I don't know, epsilon cosine t plus, I don't know, nu, maybe I'll do nu and mu, nu cosine t and mu sine t. So I expose you different Greek letters. This is new in English, ni in Greek, mu in English, mi in Greek. All right, so that would be a good guess if it didn't coincide at all with any of the solutions of the homogeneous equation. Now, the problem is that we have some overlap. In particular, we have some overlap with the solutions of, right here. We have some overlap with the solutions of, where are they? So the solutions here have up to the square. So we have an overlap here, here, and here, multiplied by these guys. All right, well, then we need to upgrade the guess. Second guess. How about I upgrade it by 1 power? T times that, so I'll write it. Alpha t to the 4 plus beta t squared plus gamma t squared plus t cubed plus gamma t squared plus delta t multiplied by the cosine t plus mu sine of t. Would that work? No, there's still overlap. This one and this one are overlapping right now with these two. All right, sorry, with these two and these two, yeah. Okay, bad guess then. What about a third guess? So a third guess is, okay, how about if I multiply by t cubed? So that would give me alpha t to the 5 plus beta t to the 4 plus gamma t cubed plus delta t squared, and then mu cosine t plus mu sine t. Ah, not good. We still have a little bit of overlap. So finally, the fourth and final guess is multiplied by t to the 4, right? Sorry, multiply this and multiply by t squared by t cubed. The original solution, t cubed plus beta t squared plus gamma t plus delta, that multiplies nu cosine t plus mu sine t. Okay, so the particular solution, the good guess is, let's just write it together, alpha t to the 6 plus beta t to the 5 plus gamma t to the 4, okay, plus delta t cubed, there we go, and that multiplies nu cosine t plus mu sine t. All right, and that is the final solution of the exercise. I mean, not the final solution of the exercise, the solution, the particular solution, the right particular solution that would work with this problem. All right, I hope it is clear how we upgrade the solution when they overlap with the homogeneous solutions. And if there are any questions, please do ask them in the in-person sessions. Now, what happens in the case, there's one more thing to say, that what happens in the case that you have, instead of a product of functions, a sum of functions. That's really easy, okay? Let's do one example. All right, so what happens when we have something like that? Ax dot dot plus 4x equals e to the 2t plus t. So it's a sum of two functions, not the product. So what we do is we call the particular solution that we're gonna find is gonna be the sum of particular solution 1 plus particular solution 2, corresponding to two separated problems, one with this one with this one. Could you make a guess that it's the sum of the guesses? Yes, you can, but it's much simpler if you work like this. Let's do this particular example. Let's solve it fully. This one. So this one, first thing is find, as usual, xh. For that, we write the characteristic polynomial. And in this case, it's lambda squared plus 4. And then we see that in this particular case, lambda squared plus 4, the solutions are that lambda is equal to plus minus the square root of minus 4. Okay? So then what we have here is lambda is equal to plus minus 2i. All right? So in that case, we know that this is a pair of simple complex roots, complex conjugate roots, and we know that the solution would be, in fact, I'm going to write it here. The solution to the homogeneous problem is C1 cosine of 2t plus C2 sine of 2t. How do I know that? Because alpha is 0, theta is 2. If alpha were, so this is multiplied by the exponential of alpha t, remember that, because when alpha is 1, you would have to add it. When alpha is different from 0, I mean, you would have to add it. Alright, so now that we have the solution to the homogeneous problem, let's solve the two independent particular solutions problem. So let's find xp1, that is a particular solution of x dot dot plus 4x equals e to the 2t. Then the guess, xp guess would be very easy, is a to the e to t. Wonderful. So this is my guess for xp, which means that xp dot would be twice a e to t, and xp dot dot is equal to 4a e to the 2t. Right, we plug this into the equation and we get the following. So we get 4a e to t plus 4a e to t equals e to t. The exponentials cancel everywhere. So what I'm left with is that 8a is equal to 1. So I found that a is equal to 1 over 8. That's nice. So xp 1 of t is equal to 1 over 8 e to the 2t. Nice. We have one of the ingredients. Another ingredient, we need the second ingredient. So let's find xp2 particular solution of x dot dot plus 4x equals t. Okay, so the guess here is a first order polynomial, so I'm gonna make the guess xp equals alpha t plus beta. None of those c coincide. The solutions were sines and cosines, so neither the exponential or the polynomial coincide, overlap with it, so we can safely continue. All right, easy then. xp dot is equal to alpha, and xp dot dot is equal to 0. Wonderful. So what we get is, if we substitute, is 0 plus 4 times alpha t, 4 times alpha t plus beta, plus 4 beta, equals t. Alright, so now we write the equations of all the coefficients. Again, coefficients of t to the 1. So on the left we get 4 alpha, on the right we get 1. That means that alpha is 1 over 4. Now, coefficient of t to the 0, the constant terms. So we have 4 beta on the left and 0 on the right. So that means that beta is 0. Wonderful. I found a particular solution too. xsp2, right? 2, maybe I should write the 1 here. Do not forget. p2. xp2 of t is equal to 1 over 4 t. Wonderful. If I combine the three of them to find the final solution, remember x homogeneous, or x of t is the sum of the homogeneous equation plus a particular solution of the full system. And because it's additive, it's a linear equation, the particular solution to the full equation would be the sum of the particular solutions of the partial problems. So this is xp1 plus xp2, right? And then if we substitute, we get that x of t is equal to c1 cosine 2t plus c2 sine 2t plus 1/8 e to the 2t plus 1 over 4 t. And that is the general solution to the full problem. All right, so you're gonna have plenty of practice with this, with the assignments. And this ends the block about linear equations, linear ODEs of arbitrary order with constant coefficients. Now, the next thing that we're gonna do, which is the next block, is a more brief block, but connects with the deep core of something that we use a lot in physics and in engineering, which is the harmonic oscillator. Things that vibrate, or things that are approximated by things that are quadratic, that vibrate. So, meet me in the next video for the harmonic oscillator, but this is it for now. Okay? See you later.